Okay, I have an enrichment exercise for you. This enrichment exercise, the questions are harder than the usual questions that you're doing in your exercises, your worksheets, your assignments. Okay, these are more difficult. There are some Sec 3 staff. If you like to challenge yourself, maybe you want to try to do all these questions and then check your answers. Okay, I will be showing question 1 all the way to question 30 on the left hand corner. Okay, this whole column, I will show it in the first video. Then the second column, question 1 to question 26, I'll be showing it in the second video. Okay, show you the whole thing. You may want to take a screenshot of the whole set of questions. Okay, give it a try. It is more difficult than the usual question you have been doing. Okay, let's continue to factorize the remaining 26 question. Okay, question 1, can you see that there are two terms? But in the bracket, you have x minus 2y. This one is y minus 2x. They are different. They are not common factor. So we cannot bring out any common factor. So x cubed, y cubed also not the same. So we can't bring out directly. So we have to expand out. So x times x cubed will be x4 minus 2x cubed y. And then this one I multiply in, I have y4 plus 2xy3. Okay, I'm going to group the x4 with the x4, and I'm going to factorize using the difference of squares. So this is like x square square minus y square square. Okay, as for this two, I have a common factor of 2xy. So I'm going to take 2xy out. So I'm going to get y squared minus x squared. Okay, y squared minus x squared. So here, I'm going to factorize it to be xa plus b and then a minus b and 2xy into y minus x. Now over here I have x squared minus y squared, but over here I have y squared minus x squared. So I should put them to be the same. So I will change this to a minus so that I have x squared minus y squared. So you see, when negative multiply in, you're getting this one. Okay, so these two are actually the same. Why I do that is because I want to make something common. Then I can bring out common factor. So x squared minus y squared is the common factor. I bring it out. And so I'll have x squared minus 2xy plus y squared. Can you see that there's a perfect square here, which can be factorized to be x minus y whole thing square. And over here, I can factorize it to be x plus y, x minus y. So now I have a term of x plus y, and then I have 3 terms of x minus y, so cube, and that's all. You cannot factorize it any further. Okay, next question 2. Can you see the x squared term? Then this is a constant term, and this middle term is the term of x. So it looks like the quadratic expression that we're supposed to factorize. So we could do cross method. Okay, to put this into product, can I say I use a minus bx multiplied by x so that I'll get a minus bx squared, which is this one. Then here, can I put it to be a plus b and then a 1, so that when I multiply a plus b times 1, that would be by a plus b, which is the last term. This one is the first term. Okay, when I expand this out, I actually get ax and bx. And when I expand this out, I get ax minus bx. When you add these two up, you get 2ax, which is this term. Great, right? Yes. So therefore, it can be factorized to be, okay, a minus b x plus a plus b. So this is one factor. And the other one factor is x plus 1. So I'll have this ax minus bx plus a plus b and multiply with x plus 1. That's all. Okay, if there's a minus, then I can do better. But this one, no. Okay, so that's all. Okay, question 3. Can you see? X squared, y squared, x times y. So this 3 in the same family. So I have c squared minus away x squared minus 2xy plus y squared. You check, you get back this one, right? And this is actually a perfect square of x minus y. Now I have something square minus something square, so the difference of two squares, I'll have c plus x minus y multiply with c minus of this whole thing, so minus x and plus y, and that's all. Cannot simplify any further. Next, can you see that this is a square, the square of it? This is b square, the square of it. Actually, I need a twice a squared b squared, but I don't have a squared b squared, right? I cannot change this to this. So can I say I minus a squared b squared? I got to do that, right? Because only when you have a minus a squared b squared, so when you add these two together, you get your a squared b squared. Okay, so the first three terms, I'm going to group them to be perfect square. So perfect square of a square plus b square, whole thing square, right? So a square, 2ab, b square. And this is minus ab square. So can you see? This is like my difference of two squares. So I will add the two. I will subtract the two. And that's all. This one cannot combine already. This one also cannot combine already. So that's all for question 4. Question 5. Question 5. It doesn't fit into a quadratic equation, okay? But we can try to force it into a quadratic equation, quadratic expression. So 25, I say it is 5x squared square. Okay, so that's 25x4, right? And I'm going to put twice of 5x squared and then plus 1. So I'm trying to force this into a perfect square. But the original expression is this x squared, but I'm getting a 10x squared. So I need to take away 9x squared in order to make it back to x squared. So here, this 3 term form a perfect square of 5x squared plus 1. So that will be a squared plus 2ab plus b squared, right? Okay, then this one here, I'm going to change it to 3x squared because 3 times 3 is 9x squared. Okay, so now I'm having the difference of two squares. So that will be the sum and the difference. Okay, I put it this way in descending order, it looks neater. And that's all. I cannot factorize anymore already. This one very obvious. It cannot be further factorized. Oh, this one is easy. 12, right? 12, can I say it is 6 square square? A6 square, B6 square. So therefore, I'll have A plus B times A minus B. Okay, this one cannot do anymore. It will be just A6 plus B6. Okay, but this one can further be factorized to be A cubed. So I have A cubed plus B cubed, and then A cubed minus B cubed, because this is like your x plus y times x minus y. That will be x squared minus y squared, which is this one. Okay, question 16. If you want to further factorize, you can still do it. That means you're going to use this formula or this formula. Okay, so you take this to be a squared cubed plus b squared cubed. So that would be a squared plus b squared, then the square of square, which is a4 minus the product, and then plus b squared. And then the other one, this one, will be also the same. If this is plus, then this first one will be plus, the second one will be minus. And if this one is a minus, then the first one will be minus and the second one will be plus. So altogether you have 1, 2, 3, 4, 5, 6 factors. And then all these 6 factors, they are unrelated, so you can't combine any one of them. So you will stop here. Okay, you will stop here. Okay, question 7. Question 7, you actually can use y to replace your x squared plus x. So this is like y squared minus 14y plus 24. So a very easy quadratic function. So we factorize it to be y and negative 2, negative 12. So together is negative 14. Okay, so there's a y minus 2, your y minus 12. So your y here. So actually this one can further be factorized to be x plus 2, x minus 1. And this one factorized to be x minus 3, x plus 4. And that's all. They are all not the same, so you cannot do anymore. Okay, question 8 is a difficult one. Okay, question 8 is a difficult one. You can see 1, 2, 3, 4, 5, 6, 7 terms. Okay, 7 terms is not easy. What you're going to do is you take the first term and the last term. So this one becomes a cubed plus 2b cubed. Okay, so this is the first 2 terms. Okay, then I use this term, and this term, group them together also. So I have a squared plus ab minus 2b squared. So this is another term. Next, I have the leftover 2 terms. So I have 6a squared b plus 12ab squared. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to group these two together. So here, use back this kind of factorization. Okay, you can factorize it to be this, like your x cubed plus y cubed. That will be x plus y times x squared minus xy, which is 2ab, plus b squared, which is 4b squared. So this is one factorization. Then these 2 terms, we use the cross method. AA, 2BB, plus here, minus here. So we are getting the AB in the center. So we are getting A plus 2B times A minus B. So this is for these three terms, factorized to be this. Then the next two, we have common factor is 6ab. So when 6ab is brought out, I have a plus 2b. Can you see what I'm trying to do? I'm trying to make them to have common factor. In this case, the common factor is a plus 2b. Okay, so a plus 2b. So now I can take out a plus 2b as the common denominator, common factor. So I'll have all the rest, a squared minus 2ab plus 4b squared, then plus a minus b, and then plus 6ab. Okay, simplify. Only term to simplify is this one and this one. So I'm getting a squared plus 4ab plus 4b squared, and then plus a minus b. Okay, here I can factorize this to be a plus 2b whole thing squared, but no point, because after factorizing I cannot combine this into that, so we will just stop here. Okay, we will just stop here. Question 9. Okay, this is a question, looks like a quadratic equation. Can you see this? X squared y squared, and this is x times y. So I'm going to break it into abx squared. I put it to be ax bx, whereas the bcy squared, I'm going to put it with by and cy. Because it's negative, I put negative here so that I get negative ac, which is this, and then positive b squared, which is from here. Okay, so therefore I can actually factorize them to be ax plus by, bx minus cy. Okay. Question 10, similar. abx, I break it to ax bx. Okay, this question, in the question, you either have this is positive, if this is negative, okay, this has to be negative. If this is positive, if this one you want to be positive, then this has to be positive. Okay, so if I change this to negative here, so the a squared minus b squared, I can have a minus b and a plus b, so negative of it. So when I multiply this together and multiply this together, I'll get into something like this. The abx, 1 plus 1 minus cancel out. So I'm getting negative a squared and b squared, which is this term. So therefore, this quadratic expression can be factorized to be ax plus a minus b, and bx minus a minus b. So this is the factors. These two are the factors. Okay, these two are the factors. Okay, the next question is also easy. This one is just like y squared minus 13y, okay, plus 22. So if it's a quadratic expression in terms of y, you have y, 2 and 11 times together is 22, but I want it to be negative, so I have negative 2y, negative 11y, so together is negative 13y. So I'm actually getting x squared minus 2x plus 3 minus 2, and then x squared minus 2x plus 3, and then minus 11. So here I have x squared minus 2x plus 1, and this one is x squared minus 2x minus 8. So this is a perfect square of x minus 1. And this, if I were to factorize it, I factorize it to be 4 and 2 is 8. 4 times 2 is 8. I want a negative value, so I put a negative 4, a plus 2. So I'm actually getting a x plus 2 and x minus 4. So that's all. You cannot simplify and factorize it any further. Okay, next one. Okay, you can see that you can factorize this one, factorize this one. So when you factorize this, you get x minus y unchanged. This will be x plus z and x minus z. And x minus z unchanged. So this will be x plus y and x minus y. So now the common factor is x minus y, x minus y, x minus z, x minus z. And that's all, right? So we have x minus y and x minus z brought out. So the first term, I have x plus z. The second term, I have minus x minus y. So a plus and a minus add up together, cancel out. So I have x minus y times x minus z and times z minus y. So this. Okay, question 13. This is like x cubed minus y cubed. X cubed minus y cubed, I'm going to use this formula. So x minus y. So x minus become plus. Okay, and then square of this one minus already, so the next one will be plus the product of the two, then plus a minus b squared. Okay, then subtract away 2b cubed. A minus a cancel, so b and b, so 2b. Here I do expansion because there are a lot of terms that I can simplify. So a squared plus 2ab plus b squared, that's a perfect square. This is sum and difference, so you have a squared minus b squared. And this one another perfect square, but the middle term is negative 2ab plus b squared. So minus away 2b cubed. So here a plus and a minus, a plus and a minus, and so together I have a squared, a squared, a squared, so altogether 3a squared, and then I have b squared times 2b minus away 2b cubed. Common factor 2b, so I take 2b out. So I'm getting 3a squared plus b squared minus b squared. Okay, so because 2b times b squared is 2b cubed. So therefore, a plus and a minus again, and combine this, you have 6a squared b. So the product is 6 times a times a times b. So factorize. Question 14. The common factor is just x power n. So this will be xn, yn. Minus away xn, so xn times xn is x to n. Y to the power of n plus n. And then the next one is y 2m. And that's all. I don't think I can have any more common factor. Question 15. This one look like quadratic equation. Square of this, and the middle term is the product of the two. So it is actually a perfect square. Okay, it's a perfect square. Can you see this is x minus y squared? This is y minus z and a 3. So this is 3 of y minus z square. And this is x minus y square. And the middle term is twice the product of this and this. Can you see? This is 6 of the product, right? So here I'm having x minus y plus, no, sorry, not plus, but minus. Because this term is negative. So I'm having minus 3 into y minus z, the whole thing square. So I'm actually getting x minus y minus 3y, so that will be x minus 4y, and then plus 3z square of it. Next, the three terms, a perfect square of a minus b. And so I'm going to change this into a minus b also. So take a negative 5 out, so I have a minus b, and then plus 6. So use the cross method, a minus b, 2 and 3, negative, negative, so that when I multiply them, I get negative 2 a minus b and negative 3 a minus b. Together is negative 5 a minus b. This is 6, this is a minus b square. So using this cross method, I can actually say it is a minus b minus 2 times a minus b minus 3, and that is the answer. I can factorize this to be x minus 2y times x plus y. So that will give you this expanded form. Okay, these two times together will give you this expanded form. So this is 4. Can I take the z out? So I have 4x minus 5y. Then I have 3z squared. Okay, so now I'm going to do factorization using the cross method. Okay, the cross method will be x minus 2y times x plus y multiply into 3z and z Can you see this? These two times together is this one. These two times together is this one, right? So if I were to cross multiply, I have 3xz minus 6yz, and this is xz plus yz. Together, I have 4xz, which is this term, minus 5yz, which is this term. So these two make up the middle term. So now I have x minus 2y plus z multiply with x plus y plus 3z. So that is my answer. Question 18. 2 by 2, we group them. Okay, so I have x4, which is a common factor, so I have x minus 1. Here, this 2, I'm going to get 2x squared to be taken out, so that I have x minus 1 again. Can you see? X minus 1, x minus 1. So the next one will be x minus 1. So all three of them has a common factor of x minus 1. So I take all the x minus 1 out. I have x4 minus 2x squared plus 1. And this is a perfect square. This is a perfect square of x squared minus 1, whole thing square. Okay, because this will be square minus 2 times the product, then plus 1. Okay, so we get into this term. Copy this down, and not the end yet, because here we can further factorize to be x plus 1 times x minus 1. But because of the square here, so there will be a square here, there will be a square here, and there's originally a x minus 1 here. So if we combine all of them, we're going to get x plus 1 whole thing squared, and then x minus 1 power 3. Not only power 2, but power 3. Okay, these two can combine to get this. Okay, question 19. Question 19, I'm going to group the plus and the minus together, and the plus and the minus together, so that I'm using the difference of two squares. So I will have a plus b squared minus c plus d squared, and then a plus c squared minus b plus d squared. So here I combine, I get a plus b plus c plus d, and then a plus b minus c minus d. Same for this one, I'm going to have a plus c plus b plus d, the sum, and then the difference, a plus c minus b minus d. Okay, so from 4 terms we go into 2 terms. So from these 2 terms, the common factor is a plus b plus c plus d. So take it out. So we're going to have a plus b minus c minus d plus c plus a plus c minus b minus d. Combine. Okay, so take out, then the rest combine. So here a cannot cancel, c we can cancel, b we can cancel, d we cannot cancel. So we're getting 2a minus 2d. 2a minus 2d, there's a common factor of 2. So take 2 out, I'll have a minus d and a plus b plus c plus d. So I am getting this factorized form. Okay, question 20. Let me repeat how to do question 20. We have a minus b cubed plus b minus c cubed plus c minus a cubed. We want to factorize it. Okay, so we look at the first two, something like x cubed plus y cubed. So x cubed plus y cubed, we're going to factorize these two first. This one we leave it first. Okay, so we're going to factorize these two by making, this is my x, this is my y, so x plus y times x squared minus x times y plus y squared, and then this one just copy. Okay, so these two factorize to be this one. Okay, then this, there's a b, there's a negative b, cancel out, so you have a minus c. And then for this whole thing here, we will expand and see whether there's any like terms to simplify or not. Okay, so we have this one expand out, perfect square. This one expand out, and then this one also another perfect square. So all these here, we try to simplify into negative 3ab minus 3bc plus 3b squared plus a squared plus c squared plus ac. Okay, and then this c, a minus c, we bring down. Okay, here there's something that is common. Can you see this is a minus c? We also have a minus c here. So this is one factor, this is this is one term, this is another one term. So these two terms we want to further factorize it, we take out the common factor, which is a minus c. So when a minus c taken out, so we copy the whole thing, and then minus away this one. There are 3 factors here. One is taken out, so there are 2 more, and these 2 more we expand out. You will get negative a squared plus 2ac minus c squared. So now we simplified again. So we have minus a squared cancel with this a squared, c squared cancel with this c squared, and then ac we can combine with this AC becomes 3AC. So 3AC minus 3AB minus 3B squared BC, and then plus 3B squared. So after simplifying, cancellation and so on, you have this, and every one of them has a common factor of 3. So take a 3 out, and then you will have 3 times A minus C, and then times okay, I put the b squared first, then AC, then AB, then BC. So now it is factorized to be this times this times this. Okay, question 21. I want to factorize this. I see that there's nothing in common that I can bring out. So I'll have to try to make them to have something in common. Okay, so let's say if I were to keep this AB times A minus B. So for these two, I'm going to expand them out. So I have AB squared C minus BC squared plus AC squared minus A squared C, and then plus AB times A minus B. So I'm going to group the term of C with the term of C. So I'm actually getting B squared minus A squared times C. And then I'm going to group these two of C together. So C squared, and then I'm going to get A minus B. Can you see that I'm trying to make A minus B to be the common factor? So I have it here, so I need one more here. So I need this one is A plus B, and then B minus A. Okay, C. So here A minus B, if I were to take A minus B as the common factor out, so this is B minus A, but I took A minus B out, so that means I'm going to add a negative sign here. So I have negative AC, negative BC, and then this one is C squared, and then this one is AB. So now I'm going to factorize these. Okay, so how do I factorize? Maybe I group this one with this one, a positive with a negative. So I have C into C minus A, and then B into A minus C. Or if you want, you can also say, if I have C minus A here, so I want to put this C minus A also. So C minus A. If I were to put this C minus A, it means I will have this part as negative. So I have now C minus A as a common factor. Question 22. 4 terms, group 2 by 2. So A is common. So we have 3x plus 2y. Here B is common, 3x plus 2y. So 3x plus 2y is the common factor. So you have A plus B. Question 23. Group 2 by 2. X cubed, x minus y, and then you have x minus y also. So together the common factor is x minus y, so you have x cubed plus 1. We can further factorize this to be 1 plus x, and then x squared minus x plus 1. So that is a factor. Okay, 24. Group these two, group these two. So x6 is a common factor. You have x4 plus y2. Same for this one. I have y3 common. Take out, so x4 plus y2, because y2 times y3 is y5. Okay, common factor is x4 plus y squared. So take out the common factor, you have x6 plus y cubed. So x6 plus y cubed. Again, this one can be factorized, further factorized into x squared cubed plus y cubed. So you would have x plus y multiplied to x squared, so that will be x4, okay, minus x times y, so x squared y, and then plus y squared. So you have x squared minus x squared y plus y squared, and this is the same, so you bring it down, so this one factorized to be this 2. Question 24. Question 25. Okay, 25. Common factor. Can I take this one to group with this one? So I have 6x cubed y plus 12x squared y, and then I have minus 4xy cubed minus 8y cubed. Okay, so common factor from these two is 6x squared y. So 6x squared y, when I bring 6x squared y out, I have x plus 2. And then here, if I put 4y cubed out, I'll have x plus 2 also. So x plus 2 is common. Okay, not only that is common, 2 is common too. Y is common also. So 2y. So if 2y taken out, so here you have 3x squared, and this one minus 2y squared. So 2x squared minus 2y squared. This one will be messy. Can I erase it? So 2y times x minus 2 times 3x squared minus 2y squared. Okay, last question, 26. Okay, I am going to group this one with this one. So 3x squared plus 3xy. Then I'm going to group 5xy with 5y squared. Then I'm going to group 7x and 7y. So these two, I have 3x as a common factor, so x plus y. And then these two, I have 5y as a common factor, so this is x plus y. And these two, I have 7 as a common factor, so x plus y. So all of them has a common factor of x plus y. So when it is taken out, I have 3x plus 5y and then plus 7. So this is the answer.